quick and dirty. I don't know, do you want to narrow down the question, or is that sufficient, or?
Yeah, that actually answered my question. I just didn't know what to do for part C, because I got part B and A. I just didn't know what's needed for the C part, but that answered my question.
Okay.
I got stuck on that problem with the epsilon sub naught. I have the microcoulombs per meter on top, and then a number that I got from the 2 pi times 0.39, which is the radius, times epsilon sub naught on the bottom, but I didn't know what to do from there. I guess I just don't understand what epsilon is, and like how to actually get a number from that.
Oh, well, I mean, epsilon, it's a constant. So you would just look it up. 8.85 times 10 to the negative 12 in SI units, coulomb squared per Newton meter squared.
And that's what epsilon sub 0 is equal to.
Yes.
Okay, well.
Also, Coulomb's constant, 9 times 10 to the ninth,
Yeah.
or the electrostatic constant, is equal to 1 over 4 pi epsilon sub naught. Or if you really want to figure out what epsilon sub naught is, because why bother answering the question unless you're just going to beat it like a dead horse? C for the speed of light. So 1 over mu sub naught, epsilon sub naught is equal to the speed of light squared. So epsilon sub naught is equal to 1 over mu sub naught c squared. Speed of light is an exact number, so you can look that up. And then mu sub naught in SI units is 4 pi times 10 to the negative 7. That's 11 meters per ampere. Seems like every semester I have to go back through and try to remember what the units are. I think that's right. So you can calculate what epsilon sub naught is based upon that. Oh, there's a mistake over here. Sorry to mess you up there. 10 to the positive 12. Something's wrong. No, it is negative 12. I was right the first time. Oh, one of those lovely days. Yes?
Is there a difference between epsilon and then epsilon sub naught? Am I saying it right? Epsilon.
Yeah, sub-zero also works too. I don't know why I got in the habit of sub naught. Probably some professor did it for me. The epsilon sub-zero, epsilon, the permittivity is an indication of how a medium reacts to an electric field. And there's a base value of it, epsilon sub-zero, as if I have absolutely nothing there. It's what's called free space. Like I have space with no material in it whatsoever. That is sort of a base value.
So like a vacuum or just?
Yes, you can treat it like a vacuum. And so when we stick in, so when we drop the zero, we're saying that we have some material there. I mean, it could be something like air. But the difference between the permittivity of air and of a vacuum is so incredibly small, we generally just ignore that difference. If you're doing multi-million-dollar research, yeah, take it into account. If you're taking physics 152, yeah, don't worry about it.
Yeah, don't worry about it.
So that's the difference with the zero there and without the zero there. And then, of course, again, with only 100 characters, capital and lowercase Greek and Roman letters, it probably gets repeated a couple times for something else. Mu, for example, there's a video I also have, but we'll eventually get to, I think there's 5 different mu's we deal with in this course that all mean something slightly different. Or in some cases, very different.
So it is not only the coefficient of friction.
That is correct.
Such a bummer.
And then it brings in even more stuff if we bring in the 151 stuff.
Feels like we learned that so long ago.
Right?
Coefficient of friction. Okay. Thank
You know, it was pre-Omicron, but we'll start a new
There we
calendar.
go.
Pre-Omicron, post-Omicron.
Right.
That was the first outbreak of COVID. That's my last one too.
Whew.
So long
Cannot
ago.
imagine.
Remember going into stores without a mask on?
No, I don't.
Yeah.
It just all blends together. I feel like I've been doing this my whole life.
Right.
That like 1 month over the summer though, it was like June to
Oh,
July.
Yep.
Yeah.
I remember like going to work and looking at people's faces and being like, wow, that's what you look like.
Right.
Yeah.
It's weird. It's always so weird.
Yeah.
I pick out like masks, like I pick out sneakers, it's just a part of the outfit at this point.
I will say that the times that people I see drop their mask, students I see drop their mask for a drink of water or something like that, my thought in my head is always, that is not what I expected them to look like. Yeah.
Every time.
All right, that second bell was that it is time, so.
Thank you.
Thank you. I will say that, I guess sort of a teaser then, because we will deal with chapter 19. Potentially, we'll do a little bit on Wednesday for the lab, but Friday we'll hit it more hardcore.
Speaking of labs, I had a question on the lab that was due last Friday that I'm still stuck on. So,
Okay, well, at this point, I guess individual, just come up with a question as opposed to for the whole class. I'm gonna stop the recording.